Okay, so I don't have a medical database. I've been showing you the interactive ways, and that's perfectly fine. But you still can write scripts. So all I really have to say is create database, the name that I want, and then switch to using it, and then I'm ready to go working in it. By the way, I know I asked you at the beginning of the term to make sure you always set the recovery mode to simple. Well, I changed the model, so that by default it will be simple. Remember, it's always based on the model. I thought, why don't I just do that? So I did. Okay, so there we go. Now I have my database and I'm using it, my medical office. So I'm ready at this stage to create the doctor-patient tables. Just going to review that quickly. So we have them up here in content categories. Right down here, our create doctor-patient table script. And there we go. So I'll make sure I'm still working in my medical office, and I'll just execute that. And successfully did. So I have my doctor and patient, so we can play doctor today. Oh, come on. All right. Okay, that was bad, I know. Okay, so I'll just come down here. Oh, I have to refresh. Silly me. Find my D-Stovall medical office. Quick review here. I'll add a diagrams just so I can look and see what I'm working with. Yes, please give me support for diagramming. I'll add both tables. Right? And there it is, our simple one-to-many relationship. Okay, where I can actually, I like to show it pointing at the appropriate ones. Right? So doctor has many patients. This is the primary care physician. I think I mentioned the other day, obviously in a larger system, you don't go into the doctor office and say, oh, I can't see any doctor but this one.
Are you in this class? Shut up. I've been hearing the whole time.
Okay, so that's our setup here. All right, so we're going to deal with this with following our instructions. So our first one is the dual key system. As you notice, every one of these tables has a simple ID. It's an integer identity primary key. Okay? But we have a business rule we also want to implement. For the patient table, the OHIP number should be unique. So we want to do that with a secondary index. Right? I could do that in code. In fact, you'll probably notice here, if you look at the very bottom of the script, I commented out this line. Create index unique patient OHIP. So it can be done in code too, but I'm just going to show you interactively for today. So here's patient. I'll right click. We'll bring up the design. So when we do this, as you recall, we have our magical little toolbar here. Okay, manage indexes and keys. So here I can, I hate that when that happens. I can come in, notice I already have my primary key is set up. I didn't have to create that, except that I did click that this was going to be a primary key. But over here I can specify what columns and so on. I'll add a new index. Specifying the columns with my ellipsis button, I can just pick one, the OHIP number, but just notice that I can add more. You can do a composite index here as well, right? So if it did involve multiple fields, I could add as many as I needed out of the table itself. But OHIP is all I need. I'll click OK. Is unique, I can make yes. And that's it. It would actually do the job. The only thing is I might change the name a little bit here, right? These names do become important because when we violate any of these constraints, an error message is sent down to the client, even if the client is in Timbuktu, right? And the client can read the actual text of the error message. Now, these aren't friendly to the user, but as the programmer, we can examine the message and make a decision on what kind of user-friendly message we'll give the client. So I typically will, any index I create that has a unique constraint to it, I put the word unique in, because that's easy to check if it contains that. Okay. And patient, I might even follow our practice of also mentioning the field, OHIP in this case. Okay. Unique patient OHIP. That probably would do the job. I should mention, to be fair, there's another option. You could just simply say unique key, right? And that gives the same result, but there's no difference in performance. There's no difference in anything as to which the approach. So I just usually say, is unique, yes, and away we go. All right, so that will add a new, by the way, you notice the two-letter prefix at the beginning is IX. Okay. So I'll just click close. Now it actually hasn't changed it yet. I still have my asterisk there until I click save. So now I've created that new unique constraint that no two OHIP numbers can be the same. We have our dual key system and fully in place for what we need in this particular highly sophisticated database. Just to prove it to you, let me right-click patient here. Oh. And we'll go to that option to edit. It gives me my grid where I can actually work directly inside the data in the rows, right? Let's say we're going to make a new row. I'll copy somebody else's OHIP number and paste it in. I shouldn't be able to do this if I, DD, SS, the date can be null, 2, and of course I have to have a doctor ID. I better select one that actually exists in the system. I know 1, 2, and 3 are there, so I'll pick one of them. When I tab out, there we go. There's my nice message. Okay, no row is updated. Cannot insert duplicate key, blah, 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 blah. There's the name of my index. So that's, just want to show you the kind of message you can get back, so it's important to give some kind of good name to your index itself. By the way, when you're working in a tool like this, they pretty much all work the same way. Hit escape once to cancel the last field you changed, hit it twice to cancel any changes in the whole row, just so you can get out of there. All right, good. So we got the first one done. We have our dual key system. Now for concurrency control, we're going to add a timestamp to the patient table. Don't need it for doctors. I mean, we have the same doctors in the clinic for 10 years now. Don't really have to worry about concurrency here, right? But for patient, it might be a good idea. So I already have this open. Thank you very much. So we'll just add a timestamp called timestamp. And you'll notice, as I zoom in the drop-down list of data types, sure enough, I will find timestamp. Oop. Now, I could uncheck this, but it's going to force it to uncheck because you can never have a null timestamp. That's all there is to it. It just automatically does everything. I don't have to worry about any other properties. So let me click Save. Now, if I do that same trick again, pull up the Edit, okay, all you see here is binary data. It doesn't have a way in this grid to display the information because it's binary data. It doesn't know how to show it. However, let me close that one. If I instead just do a select, okay, then we actually get to see the values here. Now, of course, it's actually binary data, so this is a hexadecimal representation of the binary data, right? But at least we can see how it's changing each one, okay? And we know that from now on, it's guaranteed any changes to the record, it will update and give you a new timestamp value. So it makes it nice and easy. We can just carry this back and forth and tell if the version of the record has been modified between when we got it and when we send it back. That'll come up more in our stored procedures shortly. All right, we're making good progress. Next thing we want to do is add concurrency, auditing, right? We want to do full created and updated on the doctor table because we want to keep track of who actually added the doctor to the system, okay? For the patient table, really just the updated information. Now these 4 names here I'm using, I got these initially from some online tutorials, and I find many tutorials use the exact same names, so I've kind of stuck with them as a sort of a naming convention because these fields are so often used, you'll find this repeated in a number of situations. So created on, created by, updated on, and updated by, right? The data types can change from one system to another, but those names are often used. So for the patient, I'm just still working in the design of that table. I can just add my updated. Remember, we don't need created here. A-T-E-D. Updated by. Now for the data type for this, it depends on the system. If you actually are working with an existing system, maybe where logged in users are identified by some integer value, then I'd make it an integer, right? But the truth is, the most common approach that security systems use across the board now is some sort of a username, right? It might even actually be an email address today, because that's become a common practice to help facilitate, where you can log in using your Facebook account over in this application, so on. Okay, to make that easy, they typically go with a full email address, but it's still just a username. It's just using an email address. So I'm going to make it a character type, and varchar in this case. I'm not using in anywhere else any Unicode. So I'll make it a varchar. The size, 50 would probably do, but you know what? I'm going to go 256. Why? Because in a lot of other security systems, that's the size that they've set as a limit for usernames, believe it or not. So might as well make it the same so it matches. Okay, so that's basically the first one. Now, probably a good practice. I don't want to encourage the use of nulls, right? We might not know who it is yet, but I'm going to take that off and get around the restriction by giving it a default value. I hate to allow null unless there's a reason I absolutely have to. So I'll go unknown. Or, you know, not applicable, whatever suits your client and your situation. But I don't know, usually works for me. It means if I don't have data coming from the client yet on who's logged in, at least I have something to put there. And that's the truth. I don't know who is responsible for changing the record. So unknown works. Okay, now update it on. Right. For this, it's a date time. So you remember last term we talked about we're encouraged now going forward to use datetime 2. Our new, more super and powerful datetime data type has a bigger cape, right? He can hold dates from a longer range of data right back to January 1st of the year 1, okay? Right through to way into the future. So it's a bigger range, plus with more accuracy in terms of decimal places. So definitely go with datetime 2. Again, no nulls. So I have to allow a default value in case I don't actually have data coming from the client yet. Obviously, the best choice would probably be get date. And there we go. So that's all set up now with all my fields. I've added the timestamp, updated by, updated on. I'll just save all that. Let me one more time run my select query on the patient. And have a look at what we have over here. So there's my timestamp. Updated by is all unknown for now, right? We don't actually have a client to blame yet, okay, for making the change. And this is interesting though. Look at that. Right down to like 0.5570, you know, how many decimal places there of a second? And yet we have all the same value. So that proves my point I was making earlier that databases are so fast that even with that small a fraction of time, they all fell within the same time window, right? So it's good as a way to check for concurrency, but it's not 100% foolproof. It is possible to get changes happening that can't be measured in the time frame that we have the smallest, even the smallest ability to measure. Okay, all right, so we're good there. I'll just close that. Now, I'm going to leave this one open as we open Doctor, the design of Doctor, because if we think about the instructions, it did say that for Doctor we want created and updated auditing fields in this table too. So here I'll share a trick with you, right? If I come back to the design of my patient table, these two rows, you can select multiple rows by holding Shift or Control, right? I can select those, Control C to copy, go to the Doctor, come down here, Control V to paste. There we go. With all the same, the default values, everything else, okay, has all been brought over from the design of the one table to the next. And while I'm here, I know I need creates as well, so I'll just come down one more row, paste again, because the properties are going to be all the same. I just need to change the name. So notice it just incremented it here, so I'll just change that to created. Get rid of the one. Created by, and that's going to be created on. And there we go. Now I've added the 4 fields with all the necessary default values and everything else, data types the same. All right. So we're done all of our design changes to the table to support this real world programming approach. We have a dual key, we have our business key enforced with our secondary index, we have a timestamp for patient, we have auditing fields in both. Bada bing, bada boom, we are good. No, I don't need that. Don't even need this. Don't even need that. Okay. All right. Let's come back. What's next? The other day we did a function where we passed in first, middle, and last names, right? Just to show you a twist on that, we're going to create a user-defined function that takes one parameter, the ID of a doctor. And the function returns a string, doctor, last name, comma, first name format. Okay? So it's a slight variation on the function we did on Tuesday, but it's going to be useful to show that and use it in our next step, which is the final one we'll get to today, is our patient view. All right? So I think I can just quickly do this before we have a break, because I'm going to pull up and utilize some of the work we did the other day. Remember here in programmability, we have, oh, you know what? I deleted it, didn't I? I dropped the database. Ah, darn. Remember I said those keep living there, you don't have to worry about it, saving your script? Oh, well, that's all right. So we'll call a break then, because I don't have that to copy and paste from. Oh, I might have done it up in this one. But anyway, we'll call a break anyway.